Okay, and we're going to plot this as a line and then see how well these data points fit a straight line using a regression analysis from statistics. So the first thing we're going to do is input the data into our calculator. And to do that, we have to hit Stat. So hit Stat, and it is right here. Then you click Enter, where the cursor is on Edit. Hit Enter. And it gives you two columns. I'm going to clear the data I have in here by going up to the top and hitting Clear Enter. I'll now move my cursor over up to where it's on L1 and hit Clear Enter. That's how you clear the data. Now L1, the first column, will be my X. So I will enter my time data there, my 0 to 3600 seconds. I hit 0, I hit Enter. I hit the next number, 120, I hit Enter. I hit 300, I hit Enter. I'm not sure I can pause this, so I'm just going to keep going. 600, 1200, 1800, 2400, 3000, 3600. That is my X. Now I'm going to move over to my Y column. This is where I'm going to enter what I am plotting as Y. I am plotting the natural log of the concentration of hydrogen peroxide. The first number I had was 0. Then I had minus 0.0943. Then I had minus 0.248. Oopsies. Go back. Minus 0.527. Enter. Minus 0.994. Enter. Minus 1.514. Enter. Minus 2.04. Enter. Minus 2.5. Enter. Minus 3.00. Okay, that's my data. This should really be 3.0 minus 3.00. Oh, it just left it as that. Okay, so now I'm going to, the next thing, after I've then you enter your data. That's the next step. Enter data for X and Y. Your next step is to hit second and Y equals. This is a Y. So they are here. This is your second button. That blue one right here. I hit that. And now I'm going to hit Y equals, which is up here. This one. And it should say stat plots, and your first plot should be on. If it's off, you would hit enter, toggle over on top of it, turn it on, but mine is on. So the next thing I'm going to do, I could just look at the graph. We'll do that first. If you want to look at the graph, you hit zoom, which is right here, and then go down to number 9, and I got an error. So we'll go to Window. Well, we'll clear our error. Window. I wonder if this is going to be second order. Anyway, let's do our linear regression. We might have gotten an error because it doesn't make a straight line. So we're going to hit clear. Oh no, I didn't want to do that. Oh, darn it. What is my X min? We'll put it, I think it was minus 10. Okay, I'm going to hit stat now to get back. So to see if this fits the equation for a line, I need to hit stat and then scroll over and hit calc. I'm going to calculate. So I move my cursor over, I hit this arrow here. Now the cursor is on calc, and I hit enter. Okay, then I'm going to scroll down and hit calculate. So I'm going to press this and scroll down until it's on calculate, and then I hit enter. No, I didn't want that one. Damn it. Okay, we're going to hit stat again. We're going to go to calc. And then after you hit calc, we need to go down to linear regression, which is number 4. So after you hit calc, you go down to 4, which is linear regression, and then hit enter. And then you scroll down again to hit calculate. Okay, so this gives us, this up here says y equals ax plus b. A is your slope, b is your y-intercept. It tells us our slope here, so I'm going to write that down on my paper. My slope is minus 8.356. My y-intercept is negative 0.004, because I might have to use these. Now, the way I know if these data points that I put in, the ones that we typed into L1 and L2, fit a straight line, is from my r-squared value. That is called a coefficient of determination in statistics. The closer it is to 1, if it's close to 1, it tells you that those points fit a straight line very well. And 0.999 is pretty close to 1. 0.93, 0.95, 0.98, that would not be close to 1, but 3 nines is. So this is a good straight, this data does fit the straight line, this data that we plotted, which was the constant, the natural log of H2O2 versus time. And since that comes from or fits this equation, that is a first order integrated rate law, that means this decomposition reaction is first order. So we'll write that down. It's first order in H2O2, which is our only reactant. Now, what are we going to do with this A and B that we wrote down? A was our slope, because it was y equals ax plus b. And if we go back to our equation here, the slope is minus k. So minus k, k being also our rate constant, equals minus 8.336, which means k equals 8.336. So now we know our rate constant. Okay? So if we were to write the form of the rate law, not the integrated rate law, that would be rate equals k, which is, now we know is 8.336 for this one, times H2O2 to the first power. I think you have to write a few other things down here. But that is how you use your calculator to figure out if it's a straight line. And it's much better to do this and look at r squared than to just look at the picture to see if it forms a straight line. I don't know why we got an error when we did that. We can try it again. Zoom. Yeah, I don't know. There's some data that's weird. But anyway, needless to say, this is a straight line. This is first order, and this is how you figure it out. And you use your r squared value to see if it fits a straight line. If it was not a straight line, if our r squared had been 0.98, then we would have gone back to the drawing board. We would have calculated 1 over H2O2 concentration, plotted that versus time, and seen if it was second order. So I'll go ahead and put these instructions up on Vision.